runs at constant speed to catch a bus. So, man, bus. And yes, I draw like my 4-year-old toddler, but here we are. Now, okay, he's 40 meters from the bus. Now, the bus starts at what? The bus starts at rest, and it starts to accelerate with acceleration A. The man just catches the bus. What does that mean? Literally as he, oh, I see him locked in here. So we're going to do a future self here. He just gets to touch the back of the bus. And then what happens? The bus moves away from him. So at the point where he touches the bus, velocity of the man equals velocity of the bus. The v values are the same. And then the bus goes too fast and goes off into the distance. Is that right? Now, here's the way to think of it. Let's go for the man. What's the man's starting speed? 0 or u? Why is it u? First line, right? His v value? Let's call it v. His a value? Why is it 0? No, yeah. His s value, will, for argument's sake, we'll call x. Is that okay? In a sec, yeah. I'll get there. And his t value is 20 seconds, right? Bus. U value? V value? The same v. Yeah? A value? I don't think we know, do we? No. S value, for argument's sake, we'll call it y. The man has to make up an extra 40 meters. So x is actually equal to y plus 40. Does everybody get that? Distance x is the same thing as distance y plus 40. T value, 20. Got that? Okay. Now, the phi values seem important, don't they? Why do they seem important? They're the same, aren't they? So, have an idea. Now, this one, if we use phi equals u plus at for the blue information, what's the only thing we're going to find out? We're going to find out that phi and u are actually the same thing, aren't they? Oh, in fact, that eliminates one of the variables outright, doesn't it? Just look, phi equals u plus 0. Phi actually equals u. So, yeah, exactly. Yeah, exactly. You do know that. So, in fact, when I was setting up my UVAS system, everything should have been a u. All right. Good. Let's do phi equals u plus at for the red system. What do we get here? U equals 0 plus 20a. So u equals 20a, right? We might need that later. We may or may not need that later. We'll find out. Easy information, though, right? Now, v squared equals u squared plus 2ax, or s equals ut plus half at squared. I'll go for ut plus half at squared. Okay, so what's ut plus half at squared? Using the bus. So what is it? 10. Sorry. So it's 0 times 20 plus a half a times 20 squared. What do we replace s with again? Letter y, right? And what do we get? 400a, which is going to be 200a, anybody? Okay. Now let's do the same thing for x, which is the distance of the man. So x equals what? U times 20 plus what? A half 0 times 20 squared. You guys okay? Now, what do we got here? X equals 20, u. Now, remember what we said earlier. What did we say all the way up here? X equals y plus 40. So what would that translate directly into? 20u equals 200a plus 40. Now, what's the problem with that? Two variables in one equation, right? So what about our u equals 20a? We can cash in on that, can't we? So replace u with 20a. So 20 times 20a equals 200a plus 40. 400a minus 200a. 200a equals 40. And then a equals 40 divided by 200. A equals a fifth. Right? And we also said that u equals 20 times a. So what's 20 times a fifth? U equals 4 meters per second, and that's meters per second squared. What was the goal of the question again? Find the constant speed of the man, which we all know is 4. Okay? Now, if his constant speed of the man had been 3 instead of 4, show the closest he gets to the bus is 17.5. So what does that mean? We're going to have to reset the question now, aren't we? So we reset the question. Now what do we replace u with? 3's, yeah? Does t equals 20 have any merit? T equals 20? No good anymore. Why is it no good? Anybody tell me? The time will be different because you're not running 4 anymore. You're running 3. Okay, next piece of information that will be different. Let's go to the other side. What's the bus's situation? When does it get its maximum lead? What's the deal with the maximum lead, lads? The speed is the same. So he's running after the bus. He's going 3. But the bus is further down the road and it's also going 3. And there's still a distance d between them. You understand that? So I'd argue that the distance the man ran, which is x plus d equals, sorry. No, I'm wrong. Give me a sec. Yeah, I know. Sorry, I'm wrong. The deal is that the original distance was 40, wasn't it? Everybody happy the original distance is 40? And because it gets closer, yeah, this means that x has to be a bigger number than, would you agree that x has to be bigger than y? Because he actually closes in, right? So what we're trying to do is we're trying to figure out that the distance x take away the distance y. We're hoping that distance x take away distance y is actually 22.5. Why am I hoping for 22.5? Because 40 take away 22.5 is actually 17.5 meters left. So we're hoping the man covers an extra 22.5. So we're going to do x take away y here. And we're hoping that's 22.5. Is that okay? Now, what about the bus? What do I change its information to? This is, what is it? 3. What's the acceleration? Same as the last question. What did I get for acceleration for this? Was it a fifth? Okay. And what we're going to do again for this type of question? Greatest distance in front is always a v equals v. Yes. So the man is at constant speed, okay? So the bus is moving slower at the start. So what happens is the man is getting closer to the bus. So the man is going 3 at the start. And when the bus is moving at 1, the man closes into the bus. But eventually the bus will accelerate up to 3. At that point, the man will no longer catch the bus. So that's the closest he's going to get. A second later, the bus will be traveling 3.1 or 4 and it'll start to pull away again. So all you need to know is that for a greatest distance question, your phi values have to be there. Same, is that all right? So we're going to say phi equals phi. What formula do you want to use for the first one? I have an idea. Let's use phi equals u plus at. And what's the phi value here? The u value? 0. The a value? 1/5. T is no longer. Why is it no longer 20? Yeah. 1/5 of t is 3. So what's t? 1/5 of t is 3. So what's t? 15, everybody? Multiply 5 by 3. 15. Next thing we're going to do is find out what x is. You happy with that? So x equals ut plus a half at squared. This is for the man. X equals, what's his u value? 3 times 15. And does the man have any acceleration? No. So what's the man? How far did he cover? He covered 45 meters. Okay. So the man covered 45 meters. Now what about the bus? Which is y. How far did the bus travel? We're using ut plus a half at squared again. The bus started from rest, 0, the t value, and then a half times a fifth times t squared, which is going to give us an answer of 22.5. What do we say x is? 45. What do we say y is? 22.5. How much extra distance did it make up? No, it made up 22.5 extra meters, but the initial lead was 40, and then 40 take away 22.5, 17.5 meters.